Okay, guys, so these are two very challenging problems from homework number 3, the motion and gravity. Um, and, and I wish, of course, anytime you use problems that you don't write yourself out of a textbook, you kind of wish there was more details. So we'll do the best we can. This is a problem about shooting a free throw. And of course, as soon as you shoot the ball, the only force acting on it is gravity. And that means it's going to go through that parabolic path that is known by projectile motion. Um, and so they give us a couple of parameters for this particular problem. So I drew a picture. The ball shot at 7.2 meters per second. I have the height of the release, the height of the basket, and the length between the release to the basket. And they're asking us what angle should the ball be shot at. And so I would go ahead and take that velocity vector and to break it into components. Write the velocity initially in the x is 7.2 cosine theta, and the velocity initially in the y is 7.2 sine theta. So as we set up our kinematics information, I have my x separate from my y. Notice in the x direction I only have 3 variables because we ignore air resistance, which means once the ball is shot, it will not accelerate or decelerate in the x direction. Therefore, you can use the constant velocity equation of v equals d over t. In the y direction, I struggled to decide whether they wanted us to make the ball stop right at the top, but I decided they didn't say that specifically, so I'm not going to use v final y as any number that I know. I'll say v initial y is 7.2 sine theta. The acceleration on the way up is negative 9.8 meters per second squared. The height that it will rise from where it's shot to where the top of the basket is 0.55 meters and for some amount of time. Okay, so I started off and I went ahead and wrote an equation using v equals d over t in the x direction, and I ended up with an equation with 2 variables, t and theta. In the y direction, I chose the equation without v final since I don't know anything about v final, and I wrote d equals v naught t plus 1/2 at squared. Now this is just ugly algebra. From here, I took the t value and I substituted in. After I've done that, I have this 0.55 equals the 7.2's cancel, and I know sine over cosine is tangent theta, so I rewrite that as 4.57 tangent theta. And then I have this value, which if I do a little bit of, 4.9 times 4.57 squared divided by 7.2 squared, I should get 3.38 over cosine theta squared. And of course, 1 over cosine theta squared is the same as secant squared. And I get this function that honestly I used solver for. Now I didn't have my nice calculator at home, so I used Wolfram Alpha. The problem with Wolfram Alpha is it tends to have everything set in radians, and I need it in degrees. So hopefully you could do this on your solver and get a better result. With my information, I got theta's 127, or if I flip the picture around to make it a first quadrant shot, I had about 53 degrees. The answer key had 54.6 degrees, and I think the difference between the two is probably just the calculator that I had at home as opposed to actually keeping the information in the calculator and copying it through. But hopefully that helps solve that problem. Number 10's a little bit better in that, let's see, here we go. This is a girl kicking a ball off of at a certain velocity at an unknown angle off a building. It goes up and comes back down. They tell us how far away it hits, and we're supposed to solve for how tall the building is. So again, let's see if I can move this over just a little bit. I drew a picture, and I have my information for kinematics. In the x direction, I only have 3 variables because there is no there's no force in the x direction, so there is no acceleration. Therefore, we can just use v equals d over t, which is an equation we can only use when there's constant velocity. Going up and coming down, it will decelerate due to gravity and accelerate due to gravity, so I set up 2 different columns. On the way up, I actually have 3 numbers. I know the speed it's kicked at and the angle it's kicked at, and so I actually know how fast it's moving in the upward direction. I know it will stop momentarily at the top of the parabola because of gravity, which means I can actually figure out how high up it goes and how long that takes. On the way back down, I know it starts from 0. I have no idea how fast it's going in the y direction right when it hits. Here's gravity. I wrote this as d plus y naught because it will fall down d plus the height of the building that they call y naught. And I wrote the time as 5.7 minus the time to go up. Well, that 5.71 came from me doing a little bit of work. I took Vx equals x over t, which means t equals 71 meters divided by 17 cosine 43, and I end up with 5.71 seconds. So the whole time for it to go up and come back down is 5.71 seconds. Okay, so let's see, what did I do here? I then went ahead and decided to solve for the time it took to get up to the top. I used the equation v equals v naught plus at. Right here, I solved for v naught, and I got an 11.59. Plug and chug, and you get a time of 1.18 seconds to get to the top of the parabola, which means it has 4.53 seconds to come back down. I also solved for how high up it rose by using v squared equals v naught squared plus 2ad. Substitute in my values. I got that it rose a vertical height of 3.43 meters above the horizontal to the building top. On the way back down, I then had enough information where I could solve for how far it fell using d equals v naught t plus 1/2 at squared. And when I did that, I got 100.6. So I subtracted those two, ending up with a value of 97 point, I can't read my own handwriting, I think 97.17 meters. Again, I was using my phone calculator. I don't have my nice calculator at home right now. So you might get something a little bit better looking with using a scientific calculator that carries the decimals all the way through as you're doing the work. But that process is correct. All right, hope that helps. Thanks, guys.